golden ratio is a special number approximately equal to 1.618. It is commonly found in nature, and when used in design, it fosters organic and natural-looking compositions that are aesthetically pleasing to the eye. Golden ratio it is also called Fibonacci sequence, and it can be found across all of nature. Since we talk about golden ratio that are commonly found in nature, here are some examples. First is flower petals. The number of petals in a flower consistently follows the Fibonacci sequence. Each petal is placed at 0.618 or 360 circle, allowing for the best possible exposure to sunlight and other factors. Tree branches. The golden ratio, or what we call the Fibonacci sequence, can also be seen in the way tree branches form or split.
Fibonacci numbers have an interesting attribute. When we divide one of the Fibonacci numbers to the previous one, we will get results that are so close to each other. Moreover, after the 13th number in the series, the division will be fixed at 1.618, namely the golden number. Fibonacci sequence is a series of numbers that follow a unique integer sequence. These numbers generate mathematical patterns that found in all aspects of life. The patterns can be seen in everything from the human body to the physiology of plants and animals. The Fibonacci sequence can be also seen in a way that tree branches form or split. A main trunk will grow until it produces a branch, which creates two growth points. Then one of the new stem branches into two, while the other one lies dormant. This pattern of branching is repeated for each of the new stems. Examples of these is the sneezeworts, root system, and even algae exhibit this pattern.
Symmetry.
Symmetry comes from a Greek word meaning to measure together. It is also widely used in the study of geometry. And symmetry, it is a shape that exactly looks the same as the other after a movement, like after you flip it, rotate, or slide. And there are types of symmetry. First one, we have rotation symmetry, or also known as bilateral symmetry. So reflection symmetry is a mirror effect, or it is the same image after you flip it. Here, an example of reflection symmetry, which I just get it from our backyard. So this leaf is an example of a reflection symmetry. First, on this leaf, you see here a line in between this one. So this line is what we call the axis, which is a line in symmetry, an imaginary line, which will divide the object into two. So this side is look exactly the same as this side. So they mirror on each other. So that is an example of a reflection symmetry. Another type of symmetry is a rotation symmetry. A rotation is also known as radial symmetry. So radial symmetry is when one object is rotated in a certain direction and it still looks the same. So I have your example, this one. This flower, which if we're going to rotate it this way, it still looks the same as what the flower looks. So this is example of a radial symmetry. And another example of symmetry, we have translation symmetry. Translation symmetry is something is undergone movement, either a shift or a slide on a specified distance without rotating it, without reflection, and it still looks the same. I have your example of translation symmetry. These vine leaves that I have, so they are translation symmetry because they are shifting horizontally and they have the same image as the other. So that is translation symmetry.
Spiral.
Have any of you know what spiral is? The spiral is a curved pattern that focuses on the center point and a series of circular shapes that revolve around it. Just take a look of this example. As you can see, there's a curve that focusing in the center on it. And the second pattern of nature that I will discuss to you is
Cracks.
cracks is a pattern of indicate whether the material is elastic or not. In a tough, fibrous material like oak tree bark, cracks form the relief stress as usual, but they do not grow as long they grow is wrapped by bundles. And here is my example. As you can see, the pattern of this thing is very natural as you can see in the video.
Tessellation.
A tessellation is created when a shape is repeated over and over again, covering a plane without any gaps or overlaps. So tessellations can be accurately described as tiling. Tessellation consists of a repeating pattern, one or more shapes. So I'm gonna show you the example of tessellation.
There are a few qualifications for a pattern to be a tessellation. These include shapes cannot overlap. Shapes cannot have space between them. The patterns are created by rotations translating or reflecting the shapes. Tessellations can be found in many areas of life: art, architecture, hobbies, and many other areas hold examples of tessellations found in our everyday surroundings.
Wait.
Wave is one of the patterns in nature. Wave is a physical phenomenon characterized by its frequency, wavelength, and amplitude. In general, waves transfer energy from one location to another, in which case they have a velocity. Examples of these are sound waves, electromagnetic waves, and light waves.
Fractal.
A fractal is a never-ending pattern. Fractals are infinitely complex patterns that are self-similar across different scales. They are created by repeating a simple process over and over in an ongoing feedback loop. Fractal is a kind of pattern that we observe often in nature and in art. Some of the most common examples of fractals in nature include branches of trees, broccoli, animal circulatory systems, snowflakes, lightning and electricity, plants and leaves, geographic terrain, and river systems. So why are fractals important? First, fractals helps us study and understand important scientific concepts, such as the way bacteria grow, patterns in freezing water or snowflakes, and brain waves. Their formulas have made possible many scientific breakthroughs. Second, fractals are also important because they reveal a new mathematical discipline of study related directly towards the study of nature and the world.
Meander.
Meanders are part of the dendritic patterns. When a river shifts its channel within a valley or it swings from side to side as it flows across its floodplain, it produces a meander pattern. Meander includes a series of curve, loop, bends, turns, or windings in the channel of the river or other watercourse.
Foam.
A foam is a substance made by trapping air or gas bubbles inside a solid or liquid. Foams formed by gases and liquids including sea foam, fire retardant foam, and soap bubbles. Foam in nature commonly occurs in water with high organic content such as productive lakes, bog lakes, and streams that originate from bog lakes, wetlands, or woody areas. There is also a solid form in which the examples are polystyrene foam, memory foam, and matte foam. So here are the examples.
Dunes.
Dunes may form a range of patterns including crescents, very long straight lines, stars, domes, parabolas, and longitudinal or sword shapes. Barchans or crescent dunes are produced by wind acting on desert sand. The two horns or the crescent and sleeve face point downwind. So the most common example of dunes is sand.
Stripes and spots.
So we're going to talk about stripes. Stripes are made by a series of bands or strips, often have the same width and color along the length. Nature's love of stripes and spots extends into the animal kingdom, like tigers and leopards, zebra, and giraffes.
Fractures.
Fracture is a separation of an object into two or more pieces under stress. It occurs when the applied stress is sufficient to break the atomic bonds of the solid.